Hello, everyone. Welcome to our second webinar on a series of Express 30-minute webinars on Phoenix WinNonlin. Anna Henry, as you know, has started this series last month with a session on tips how to save time creating Phoenix plots. You know, plots is a highly popular topic, so it comes up as our topic today again. I will continue to show some tips around creating plots in Phoenix. But in addition to plots created directly from the Phoenix WinNonlin function list, this session will be focusing on the use of R software from within Phoenix WinNonlin. R software is not only known as a statistics tool, it also has great capabilities as a plotting tool. So you will learn how to create some specialized plots in Phoenix WinNonlin using R. To make this application more realistic, I've embedded this topic into a popular scenario, a typical PKTK analysis workflow. We will go through a full analysis workflow, but there we are focusing just on the inputs and the outputs of this analysis. In the next webinar session in March, I will focus on the analytical part, the non-compartmental analysis, and the compartmental modeling aspects of a PKTK analysis. So let me switch the slide. Okay, since this is just the second webinar, let me remind you that all of you are muted, and there will be a 5-minute Q&A session at the end of the demo. So you have any question, then please write to the Q&A panel, and we will address as many questions as possible at the end. To access the panel, you will see there are some icons at the bottom of the WebEx window. Okay, and the goal of this webinar is to make you aware of how you can connect external programs such as R with Phoenix. And we will demonstrate how you can import and run R scripts from within Phoenix today. So we have chosen a very common scenario to help exemplify the use of R software in Phoenix. This is a PKTK analysis workflow. In toxicokinetics, we are in preclinical stage where you want to quantify the systemic exposure of your drug while escalating the doses until you see signs of toxicity. This process is highly standardized, and that is why many customers are using standardized workflows like the one shown here to analyze their PKTK studies. And it's always the same steps. You start with importing your study data. Let me see if I can get it. And you can, and then you can run some exclusions, some filters on your data sets. And then you run through the analysis and eventually prepare tables, lists, and figures for your report. So in our session today, we will focus on the plot output. First, the time concentration plots, and then what's very important is the PK parameter plots. We won't deal with table output this time and reserve this topic for a subsequent session. We also do not focus on the analysis part. This will be the topic of our next Express webinar session in a month's time. But the main focus of today's webinar will be on the creation of plots, of R plots. Phoenix can help you generate most of the plots for PKTK analysis already, but you know, I'm coming from support, so we know that customers sometimes want a rather specific plot, and that sometimes Phoenix cannot produce. And in such a situation, you may help yourself by including R plots in your workflow. That means you don't need to leave Phoenix and your standardized workflow to achieve this. Cheryl, can you see the slides? I mean, I just got a message here that somebody can't see the slides.
Yes, I can see them.
Okay, good.
You can see slides, but you can't.
Okay. Good. Let's move on. So here are the first plots. And these are Phoenix plots, and these should look familiar to you. You start with the description of your study data. Here we have in the first plot on the top right, the typical individual plot, time concentration plot, but also we are using summary plots for a specific dose or day or treatment. And once you are complete with your NCA or your analysis, you want to plot also the results, the PK parameters. And these are typically plotted with an X, Y, X categorical plot. And under normal circumstances, and I repeat myself, I would say that the plotting capabilities in Phoenix are more than sufficient. And you don't really need more functionalities, but we are living in a pretty diverse world where there are special desires all around. So, and that brings us to R. One of the desires is around shaded plots. And when we want to display uncertainties in Phoenix, we typically use error bars. This is what we've seen in the summary plot of the previous slide. But there are customers who prefer shaded plots. Here's one example, maybe not a very nice one. I have to admit I'm not an R expert. I'm sure other people can create much nicer plots, but I'm just using the standard default options in R for shading, and that is a smooth line calculated by a local polynomial regression fitting, and then you can display the uncertainty as calculated by standard errors in form of a shade. And I can show you later on how you can create this plot in Phoenix. Next slide. Another desire is split axis. This is a highly popular topic in support. As you can see, you have an axis. In this particular case, it is the x-axis that stretches over a wide range and where there's nothing happening in the middle of the axis. So people want to cut out this useless part of the axis. In our example here, we have a time concentration plot from the TK study where the time is covering all 28 days of the study. However, we only measure PK in satellite groups at the beginning and the end of the study. That is at day 1 and day 28. Nothing happens from day 2 to 27. The solution here is to break the axis in two parts, and but this is not possible in Phoenix. You have to use R for this. So I will show in the demo how you can achieve this. Yet another example, in PK studies, you always want to have a Semilog plot next to a linear plot. In Phoenix, this is typically done in two separate plots arranged next to each other. However, people like to see both representations in the same plot. So they want to arrange a plot within another plot. As shown here, you can use R to create a Semilog plot and display it in an occupied part of the linear plot. Next one. This is the final example for today, a combined box plot. One major outcome of a TK study is the display of PK parameter ratios. That is, you want to compare the exposure values between day 1 and day 28 to see an accumulation. You want to see whether there's a gender effect, and also you want to see ratios for a treatment effect. You can create these kind of box plots in Phoenix as well, but to have it arranged in this particular way, such that it resembles a forest plot, you need R software to do this. Also, the display of the individual data points in the box plot is special for R. Before we are starting to get into the demo and I'll show you how to create those plots, there are some preparational steps and I want to go through. People might not be aware of this functionality, but you can easily connect external programs with Phoenix. And this connection is set up under the preferences menu in Phoenix. As you can see, here you can connect R to Phoenix, but you can also connect other external programs such as non-mem, PSN, or ZAS to it. That way, Phoenix can become your dominant workbench. What Phoenix requires to get connected is shown in this dialog in the top line. It just needs to know the location of the R executable. In addition, you can define a development environment. Here I've taken the path to the RStudio exe, and I will show you later how you can make good use of this. So if you want to start R with specific set of arguments, there's another line. You can enter those, and finally you can define where to write the output and whether you want unique subfolders created for each R execution. So this is shown you the R script object that is used in the Phoenix workflow. You need an R script that runs as a software. This script is then shown in this white window at the center, where you are able to edit the text. In the bottom panel, you have some options. You can choose a different and the default output folder. You can select sources to be used for the R execution in the workflow, and whether you want to clear empty results and if you want to include an R workspace, which is nothing else but the actual R environment, including all input and output objects. There's a button to start the development environment. This is very useful when you want to fine-tune your script, since it allows you to switch between Phoenix and R to check that your script is working okay. There's, just for completeness sake, there's another option in the R script that allows you to filter the results from R based on file extensions or patterns or file sizes. And then just to go through the list of steps when you want to set up and run an R script. In principle, you can write the script directly into the object, in the R script object, but the more general case is that you have a script already at hand and that you need to import into Phoenix and connect with an R script object. Then you will need to select some input, and here there are two different ways to handle this. You could add a W and L in comment combined with an attach function, or alternatively you can select the source button to select an object from the workflow as an input source. And then you just execute the R script object, which launches the R software, and after successful execution, the results from the script, the different output objects are being added to the results tab of the R script object, from where you can analyze it like any other result in the Phoenix workflow. Okay, we are ready for the demo. Let's start with that. Let me share my screen. Okay, Cheryl, can you see that? Cheryl? Hello, Anna, can you see it? Hello?
Yes, we can see your screen.
Okay. All right. Just wanted to check. I mean, thanks. So this is a workflow that we've seen in the slide. Let's go through the data first. So typically for a TK analysis, you have some samples from your lab or from your biostatistics groups, sample IDs, subject groups, animal IDs, time, concentration. And the different treatments, you have some dosing records. Oops, what is that? Still seeing the slide? The Phoenix? There was some error. Anna?
We can see your Phoenix.
Okay, good, thanks. So these are the dosing records. And then what you see here actually the code, the R scripts, and these are just text objects, right? This is you can import directly into Phoenix. And so we have 4 examples that we will go through in a minute. And here is the workflow. So we start with a data import. Here, as typically you have data links, so you can always replace input when you have an update on your study or you want to run a new study. And this is just linking all the input fields with required parameter fields. Then you have some filtering rules on the samples and the dosing records to get rid of records or columns that you don't need. And then we have here the time concentration plots. Typically, as a preparation step, you run a descriptor stats on your samples data. Gives you some output about concentrations. And here you have the individual time concentration plots, which are here Semilog plots and linear plots, right? is with all the different subject groups, but also summary plots. Okay. These are the first type of plots. Here you only have an NCA for this. This will change next session when we go in more depth into the analysis of a PKTK study. And then we have, just as an example, 3 very popular PK parameter ratios, like for example, accumulation. Shows here, you have this object where you can specify an XY comparison, where you say what is the ratio of the Cmax from day 29 with regards to Cmax of day 1, and the same for AUC last, and this results into some ratios. The same you can do with the dose proportionality, where you just have dose normalized values for Cmax and AUC last, and you compare it between the different treatments. And then finally, some gender differences. You can see the Cmax or AUC last values compared between female and male animals. And this gives you then rise to these ratio values. Okay, so as I said, PK parameter plots are typically X, Y, X categorical, and they look like this, right? You have these 3 different treatments and the Cmax values, and you see by increasing dose, the Cmax values increase as well. For Cmax versus day, you have the comparison between day 1, the last day, day 29. Same for AUC last. You have some summary values on the Cmax values, for example, where you compare female versus male animals, and the same for AUC last. And also you have some X, Y, X categorical plots of the PK ratios, just a number of those. So this is showing you just a summary of what you can get out of PKTK analysis using the Phoenix functions, but here I've just added some additional plots that I've shown in the slide. For example, the time concentration, smooth plot, if you will. So this is the plot that is generated. These are just the results. You see here, you just have the samples as an input and the R script. Same for split axis. You see this one here. And plot in plot, which is shown here. This plot and the box plot. And these are objects that you can then attach to your report, maybe in a reporter object, or you can dump out of Phoenix as you normally report or get your results out of Phoenix, the standard way. What I would like to show you now is how you can create those plots. And for this, you just have to go into your code folder. Here, I've just imported these ASCII files. These are just text files that you can import through the Phoenix import function. And this is the text. And you can connect, so let me just say, you can connect this with a send-to function to an R script object. Okay, and let's put it in under the main workflow, and it will create an R script. Let's say these are samples script. So what you have is a samples input and the R script. And the R script is connected with the code, and you can edit it as an internal text object, but this is something we don't need right now. At the beginning of the R script object, it requires a specific library package, ggplot2, which is very popular and very important for generating plots in R. And then you have this attach function. It's attached to the worksheet samples, and then you've combined with the WinNonlin in statement, which contains all the or lists all the column names that you want to see. And let me just select the source from the workflow. In this case, it would be the filter samples result. And you see it already maps all the required columns from the R script. So this is being done, and now we can just look at the R script. It creates a G-plot from this data with time on X and concentration on Y. it produces some points and tries to make up a grid with regards to treatment and day and sex, and tries to also create a smooth line, and that's what it does. And if I just execute it, it will launch R from within Phoenix, come back with a result, and here you have the samples plot. Okay. Next one, we will take the split axis one. We can send this one again to an R script object, workflow, and here we are. You can already select the samples once again from the workflow under filter samples result. Here it's a different library package required for this specific plot. It's called Plotrix. And here again we have this input for the worksheet in Phoenix attached samples with those column names, and you see these are all mapped. Okay, so it will create a PNG file as output. We'll assign the time continuous column to X and the concentration to Y. We assign the value of 25 to from and 645 to 2. And then we create a plot. That's a gap plot. And on X and Y with a limitation on X-axis to 675, from 0 to 675. The gap is from 2, and the axis is gap axis. There's a label time and the limit on these, between these two. And then also we can use some ticks and define some ticks on the X and Y axis. And here we can insert a break into the axis using some from the from values and some additional statements. I mean, this is really a very simple script taken from examples from, by simple Google searches. You will find out on your own easily, and you can see this is now the split axis plot, and that's my second example. Let's go to the plot and plot, yeah. Send this to a R and R script object. This is, let's call it plot and plot. Okay, again, samples as input. We'll take the result once again from the filter step. The R script here, a number of library packages require ggplot2, grid, and grid extra. The typical combination of attach function and WinNonlin statement. We create a plot file, a PNG plot file, and we create a first plot, a ggplot from the samples with time on X, concentration on Y. We create points and a smooth line using the low-S method. In this case, we are changing the background of the plot to black and white, so we have a blank background, and also the panels that we are creating will all be blank, so white as a background for the first plot. And then we create a second plot, which is the first one with just a scaled y-axis, scaled to log 10 and a different label. So we've got now two plots, P1, P2, and we use the grop function, ggplot grop function, to treat this second plot special. And then we create a new display with the first plot plus a custom annotation with the second plot, where you define just a part of the linear plot, the P1 plot, where we can place this Semilog plot. And if we run this, you can see it easily. It will create this plot, and here we are. This is the third plot. Then the combined POX plot. That's my last example. Let me show this one. This one is not linked through the attach statement, and here you just need to select sources here in the bottom panel. So if I select sources, I just take those three input sources, And these are now mapped to this R script object, and it will here use those as data frames. And then I just need to grab some columns, some numbers from these input ratios, and then combine them, stack them on top of each other, create a file, and this is a ggplot with a geom box plot option, and some jitter points, some labels, and a horizontal line at a y-intercept of 1, which is dotted. And if you execute this one, it will build this box plot. What I wanted to show you, I mean, I'm at the end of my time, but let me start the development environment, because sometimes you're not really, you don't like the results, so you want to fine-tune your R script, and then you go simply into R. This is RStudio, where you can load up here are all the files that Phoenix produces in its object. It's just transferred into a temporary directory and is available in RStudio in this environment, and you just can check that the code is working by running this R script, and then you see it creates this box plot. This looks fine to me, so I can say, okay, go ahead with this one, and go back here into Phoenix, and you can reload the script. Okay, this is, I guess, all the things that I wanted to show. I think when I'm going back to the slides, we are at the Q&A stage. Charles, do we have questions?
Yes, we have a couple of questions. Please, if anyone has questions, type your questions in the Q&A box. So, Bernd, there's a question about the code for the box plot, if it was written or it was taken from the box plot figure. So how do you get to that code?
As I mentioned, I mean, this is really just pretty raw R code, I would say. As I stated, I'm not an R expert. So what you can do is, I mean, there's so much material available in the internet. You just have to Google it. I just looked for some keywords in Google, like combined box plot, and then you see those options. And actually, let me bring this one up. The RStudio interface is also very helpful if you want to fine-tune your script. I just showed you a small step. I mean, you can really see the options. You can see the help. What are the parameters for a certain function to find out how you can tweak it. And it really doesn't take an expert to get to these plots. This is really just maybe 1 or 2 hours time of a non-R expert to get to those plots. And I'm sure there are much better, much nicer examples out there that you just need to pick, and then you should be there.
Okay, we have a couple of other questions. Several people are asking about if these files are going to be available for everyone.
Yeah,
and,
sure.
Then there's another question about, can we use some of the output from Phoenix, for example, the residuals, as a source for these R plots?
Yes, I mean, you can use any worksheet output in Phoenix WinNonlin and combine this with an R script. It's open, and it's really, any object in Phoenix you can link with an R object to create some plots. That's not a big deal. And this whole session was just, to give you an introduction into this field, but you can, expand on this as much as you like. I mean, and if you need some help, obviously, we have either a material in Certara University, but also if you have some simple question, you can ask support.
Okay. And one last question is it possible to generate a QQ plot for 2 different data sets? That
is the same as you would do it in Phoenix, right? If you have 2 different inputs, you somehow have to combine the 2 different result worksheets into one data frame, if you will, right? Either you do that inside of the Phoenix workflow using some data functions, or you can use some R functionality. This is up to you, where you are more, fluent in bringing up the example. But it should, in principle, that should be straightforward.
Excellent. So I think this is it for our webinar today. Thank you very much, Bernd, and thank you everybody for attending.